Okay, welcome to this second tutorial on 8085 programming, and in this tutorial we will write very simple program and we will get started with 8085 programming. So this is how the interface of 8085 looks like when you start it. So just start it and type these simple line of codes. So we will come to this, but before that let us have a look at what we will be doing in today's tutorial. So we will study what registers are in this 8085 simulator, what these registers are, and we will be mainly concerned with A, B, C, D, E and HL registers in this tutorial. Now this A is called as accumulator register because whatever calculation is made in 8085 microprocessor, its result will be by default stored into this A register. So by nature it has got capability of storing the result or accumulating the result of every calculation. That is why it is called as accumulator. And remember, it is of 8 bits only. So 8 bits means you will be able to store numbers from 0 to 2 raised to the power of 8 minus 1, which happens to be numbers from 0 to 255. And similarly, here we have got these registers BC. This BC is not a combined register. B is separate and C is separate. This first 00 is written for B and this second is written for C register. And similarly DE, HL pair, etc. Now for this B register we have these two zeros. What these two zeros signify? These two zeros are nothing. This 0 is for the lower 4 bits and this 0 is for the higher 4 bits of the number that we will be storing in that. And also remember that the numbers in this will be stored in hexadecimal format only. So the numbers from 0 to 255 will be stored in their hexadecimal equivalent forms and they will be displayed here. Although inside the memory they will be all in the form of zeros and ones, but since we have used here only two zeros, so the lower one is for 4 lower bits and the upper one is for the higher 4 bits. So that is why the result will be displayed here in hexadecimal format. So these are all the registers A, B, C, D, E and HL. They are called as general purpose registers because suppose if I give you a calculation of adding 5 and 6, you will keep this 5 and 6 somewhere in your memory, in your brain. You will add them and give the result 11 immediately. You won't need any pen, paper to write 5, write 6 and then perform addition and then give results. So these are very trivial operations and inside your brain they can be performed. The CPU, which is the brain of any of the processor, has got certain inbuilt memory also. So in a similar way we can say that A, B, C, D, E and HL, they are all general purpose registers which are used by this 8085 CPU. So here I have written a very simple program. The purpose of this program is to store a value of hexadecimal 12 into this A register. It is as simple as that. So the syntax for this is written here and the first is comment line. So whatever you will type after a semicolon will be treated as a comment, and in this comment I have written hello, this is our first program. This line is useless to this 8085 microprocessor because it is a comment line. The actual program starts from line number 2, which says MVI A12H, and the meaning of this is MV is for move and I is for immediate data. So now we are trying to move some data from somewhere to somewhere. So that is A, 12H. Move immediate data into the register A, and that data should be 12 in hexadecimal. H stands for hexadecimal. This is the meaning of this command. And then HLT is for halt. When you will want to stop the program, you will type HLT and this will halt the computer. So this is all the purpose of this program is. So to run this program you need to go to file menu, then save as. Then to save this you first need to specify the path. So in case this is shown as plus here, you just open it, so this window will open and select the required path that you want to have. So I have selected this path in my computer and you need to give it a name also here. So I have given it a name as program1.asm. So this ASM extension is used for assembly language programming. So ASM is a default extension which is given, and the software is very intelligently designed. So even if you don't give this .asm extension, your file will be saved and the program is executed. But it is customary to write .asm to these files. Then save this file And to execute this, go to assembler and execute. You can also do this by this function key of F9. You don't have to go to assembler and execute every time. You can press F9 key and this will be executed. So after executing, you can see that this 12 is stored here. We have executed this program, and in this accumulator register 12 has been stored. So this is all what this program does. Now what if I change this program in such a way that h has been removed from here? Now if h is removed, you can expect this number as a decimal number, and it is a foundation that whatever you will supply as an input to this 885 processor, it will be treated as a hexadecimal. It will be treated as a hexadecimal number. So this is a decimal number that we have given, but the hexadecimal equivalent of this will be something else. So this will be treated as a hexadecimal number, and its hexadecimal equivalent will be stored into a register after execution. So let us see that. In the assembler, you go and hit execute. So instead of storing 12, 0C is stored here in the accumulator, which happens to be the equivalent of 12 in hexadecimal code. So if you're not aware of hexadecimal to decimal conversion, I would request you to have a look at that, but I believe you must be aware of this. And the hexadecimal equivalent of 12 happens to be C, so this value 0C has been stored in A register. So you have to remember that whatever you write here will be treated as in hexadecimal. So even if decimal is written, it is stored as hexadecimal number. Now suppose I want to convert a number from decimal to hexadecimal. Suppose I want to convert 25 to hexadecimal number. I want to see its hexadecimal equivalent. So this is the facility which is given to you here. You just type 25 here and then hit this button to hex, and it will give you its hexadecimal equivalent, which happens to be 19. So this is given for your facility. If you don't even know the hexadecimal equivalent of numbers, it can be done here. Now let us type another program where I write MVI A25, and this 25 is written as a decimal number, but we know that its hexadecimal equivalent will be stored. So we have already found out the hexadecimal equivalent. We can verify it if it is stored or not. So if we will execute it, 19 is stored here. 19 is a hexadecimal number, which we have seen is the equivalent of 25 in decimal. So it is stored here. Had we applied h here, so 25 as it is will be stored here, because it is mandatory to supply the numbers in hexadecimal format, or otherwise they will be converted. Now you can also see that this program counter value or the PC value has changed, but as this is not the topic of today's tutorial, so we will not be covering that. But in the next tutorial or in the next few tutorials, when we will come to these topics, we will discuss what these are. So we are mainly concerned with this A, B, C, D and HL register in today's tutorial. So by now we are aware of how to store a immediate data into some register. Now this can be done for any register, MVI L A1H. So this is a valid command. You are trying to move the immediate data into L register, and that data happens to be A1 in hexadecimal. So in this register L, which happens to be this, there should be A1. So when you will execute it, you will see an error here, undefined symbol and invalid operand or symbol. Now what is the problem in this is, when you specify a hexadecimal number and it starts with something other than a numeric value, in this case it happens to be A, because hexadecimal numbers can have digits from 0 to 9 and then A, B, C, D, E and F. So whenever there is a non-number thing here, you have to start it with 0. I mean, you have to write your code like this. So this will tell this 885 simulator that whatever is written after 0 is treated as a number. So this A1 will be treated as a number, and this is already written in hexadecimal. So now when you will execute this, this will be correctly stored in the L register, which happens to be A1. So the value has been changed here. So this is also one of the points to remember. Then now suppose I am moving in L register 52H in hexadecimal. Execute this program, this will be changed. So in this way you can use any register A, B, C, D, E and HL, and you can use it the way you want. Now why this B, C, D, E and HL are written together? There are specific reasons for that, in which we will see in our coming tutorials. so don't bother about that is at this time. And if you want to reset it, you can reset registers, you can reset flags, input output ports, memory operation. When you will click reset all, everything will be reset. So I've clicked this and you can see that everything has been reset to 0, because when we execute a program, it might happen that data inside registers is stored due to some previous programs which might interfere with our programs. So it is always a good practice before running a program, you just reset everything in this computer. So that has been done here. Now let us try to store a number 3596 in decimal to this register. Now this 3596 happens to be a very big number, and the result of execution of this program will be like this. Since we are using L register, so only 0C is stored here, but 0C is not the equivalent of 3596. So what is the equivalent of 3596? If you will type 3596 in this decimal box, E0C will be shown here. So whatever is extra, that is this E was extra, and these lower bits have been stored 0C here. So while storing things, it should be kept in mind that we can store numbers from 0 to 255 in decimal, or numbers from 0 to FF in hexadecimal format. Numbers beyond that range will not be entertained by this processor, since this is a 8-bit microprocessor. So that is the range of numbers. So this is the general introduction to these basic registers A, B, C, D, E and HL, and in our next tutorials we will explore them further. And keep watching our channel and subscribe to our channel for